we are suppose we are late and we are letting these positions for calculating. Now moving on to the next, the T2. T2 is equals to B into T1 because this is T1, so B into T1 is the next position T2. Now we again consider minus C is equals to T3. Then what will happen? Okay, the T4 position will be the B into minus C, and the minus C is denoted as T3, so T4 equals to B into T3. Now we have two positions T1 and T4, which needs to be added and saved in the T5 position. Then the position T5 is equals to the position A, so T5 is equals to A. So this is the syntax tree of code for this given example. Then now we need to generate a DAG. We have already seen that DAG is the short form of syntax tree. So here we have seen that T3 and here T1 is doing the same function. So we can use only T1 equals to minus C. Then T2 equals to B into T1. Then T3 equals to, we can directly say that T2 plus T2, this because we can say that this is T2 and this is also a T2. So T2 plus T2 equals to T3. Then we will move T3 to the A, which is the DAG code. Are you guys clear? Okay. Moving to the next type of three address statements. Some common three address statements are assignment statement, assignment instruction, copy statement, unconditional jump, conditional jump, then procedural call. Those are the statements. Then moving forward with index assignment and address and pointer assignment. We all know this basic in the our C program tutorial. Hope you guys know about this. Moving to the next, implementation of three address statement, which is very important topics for our examination. Three address representation have three qualities. First is quadruples. Quadruples means is it has four topologies. Then triples mean it has three, and indirect triples is a different kind of triples. Now moving on, quadruples. In the quadruples, we can see that here are, we have already said that it have four topologies, like one is operation, argument 1, argument 2, and the results. Then first of all we need to generate a static code. This is the syntax or static code for this instruction. And now from here we can see that here in the first line operation is minus here, so in the index is 0 to 5 and the operation is minus. Then the argument is C, and this result of minus C is stored in T1, so in the result section we have T1. Now index 1, here operation is multiplication, then argument 1 is B and argument 2 is T1, and this result is stored in T2, which is line number 2. Now in line number 3 is same, and then line number 4 is same. Then the line number 5 with index 4 says that operation is plus here, and the arguments are T1 and T2, which are T2 and T4, and the results are stored in T5. Then finally the operation is equal to, which index is 5 and the argument is T5, then the result is stored in A, which is the last line. So this is the three address code, and this is the representation of quadruples. Now moving to the next, which is triples. In triples we have three tuples, like as the previous one with the same operation. First we have the operator C and the argument is C, but where to store the result? The result will be stored from this. We can see that if we don't have this result section, we can see here the index number is 1 and here the index number is 0 and it's the index number 5, and in the index argument number we have the direct arguments, but in the triples we will use the index number instead of argument numbers. Like as we stored the value to the t1, but in here we will use the t1 index number which was 0, and in the second line we can see that we will store the result to the index number 2. Then the argument of t1 and t3 will be added and those results are saved to the index 4. Then finally we can say that equals to operation with a and t4 denotes the a equals to t5 operation. So this is the triples where we directly use the index number instead of t1, t2 and t3. Now triples have two types, which is indirect triples and triples. We have already seen triples. Now moving to the indirect triples. In the indirect triples we need to generate a statement. Like index, we generate a statement like a 0 it is 14, 1 15 to the 5 to 19, which is an statement array. In indirect triples we use statement numbers instead of our index numbers. That's the major difference between triples and indirect triples. In this section we have already seen about many topics with intermediate code generation, but the major important parts are quadruples, triples and indirect triples. Then the types of three address statements, those are very important of exam question view. Then we also need to know how to generate a DAG. The postfix notation is important for small questions. This diagram and this formula is very important for our question view. You obviously need to have a clear concept of this diagram to attempt the intermediate code generation questions. That's for today. Thank you.